Section 647.3 of the National Electrical Code, or NEC, states that balanced power systems are not permitted in single-family dwellings. Using dedicated circuits for each duplex receptacle is a good approach to ensure sufficient power and reduce the risk of overloading. Both ROMEX and EMT can be used as wiring methods. The choice will depend on the specific conditions. If receptacles are mounted on the concrete foundation wall, EMT may be necessary to protect the wires from damage. Isolated ground can help reduce noise on the equipment crown, or egg. This is because the EGC is not connected to the neutral conductor at the main panel, which can prevent ground loops. Isolated ground requires a separate grounding electrode system. This can be expensive and may not be feasible in all situations. Standard receptacles are required to be bonded to the metal box, even on dedicated circuits. This bonding ensures that the box and the equipment connected to it are grounded. Bonding the standard receptacle to the metal box does not guarantee that there will be no noise in the EGC. Ground loops can still occur due to other factors, such as improper grounding of the electrical system or the use of unbalanced equipment. Discuss the equipment and its power requirements to determine a necessary circuit capacity. A power conditioning unit can help protect the equipment from voltage spikes and other power disturbances. Ensure that the grounding system for the building is properly designed and maintained to minimize noise. If feasible, consider using an isolated ground system to reduce noise on the EGC. However, this option may require additional cost and effort. Follow all applicable NEC requirements and industry best practices when installing the receptacles and circuits. The NEC is updated every 3 years, so ensure you are referencing the most current version adopted by the local jurisdiction. Article 100 defines terms, and the specific definition should be reviewed when using the NEC. Chapter 1 contains general requirements. Chapter 2 covers wiring and protection. Chapter 3 discusses wiring methods and materials. Chapter 4 relates to equipment for general use. Chapter 5 supplements or modifies the general rules. Chapter 6 covers special equipment, special occupancies, and special conditions. Chapter 7 relates to special conditions, and Chapter 8 is on communication systems. There are also informative annexes to assist the user. It's crucial to consult the relevant sections within these chapters for detailed guidance on receptacle installations, grounding, and wiring methods. For example, Article 210 provides requirements for branch circuits, including conductor sizing and overcurrent protection. Article 250 contains the requirements for grounding and bonding, including the use of equipment grounding conductors and grounding electrode systems. Article 300 covers wiring methods in general, while Articles 310, 314, 320, 330, 334, 344, and 358 address specific wiring methods such as conductors for general wiring, junction boxes, armored cable, metal clad cable, non-metallic sheathed cable, rigid metal conduit, and electrical metallic tubing respectively. When planning electrical work, consider firstly, consulting local codes and amendments, secondly, the load calculation and circuit capacity, thirdly, proper wiring methods, and fourthly, grounding and bonding. Local codes may have amendments or additional requirements beyond the NEC. It's important to check with the local electrical inspector or authority having jurisdiction, or OJ, to ensure compliance. Accurate load calculations are essential to determine the appropriate circuit capacity and conductor sizing for the audio equipment. This includes considering the voltage, amperage, and power factor of each device. Proper wiring methods, such as using appropriate conduit or cable types, are crucial for safety and compliance with the NEC. The choice of wiring method depends on the specific application and environmental conditions. Grounding and bonding are critical for electrical safety and to minimize noise. Ensure that the grounding system is properly designed and installed, and that all metal enclosures and equipment are bonded together. Regarding dedicated circuits, this means each receptacle or small group of receptacles is supplied by its own individual circuit breaker in the electrical panel. This is beneficial for sensitive audio equipment as it minimizes the risk of voltage drops and interference from other devices on the same circuit. Power conditioners play a vital role in protecting audio equipment from voltage spikes, surges, and noise. They also help to maintain a stable voltage level, which can improve the performance and lifespan of the equipment. Surge protectors are a basic form of power conditioning that protect against voltage spikes and surges. Line conditioners provide more comprehensive protection by filtering out noise and regulating voltage. Uninterruptible power supplies, or UPSs, provide backup power in the event of a power outage, allowing the equipment to continue running without interruption. When installing receptacles, follow NEC guidelines for spacing, mounting height, and accessibility. Receptacles should be mounted in accordance with ED guidelines, if applicable. Use appropriate boxes and covers for the receptacles, ensuring that they are properly grounded. The equipment grounding conductor, or EG, is a critical component of the grounding system. It provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker and protect against electrical shock. Ensure that the EGC is properly sized and connected to all metal enclosures and equipment. Ground loops can occur when there are multiple ground paths between pieces of equipment. This can create noise and interference in audio signals. To prevent ground loops, use a single-point grounding system, where all equipment is grounded to a common point. Balanced audio cables can also help to reduce ground loop hum and noise. Isolated ground receptacles are designed to minimize noise by isolating the receptacle's grounding terminal from the metal box and conduit system. They are often used in sensitive audio and video applications. The NEC requires that isolated ground receptacles be installed in accordance with specific requirements, including the use of an insulated grounding conductor. When using EMT conduit, ensure that all connections are properly tightened and grounded. Use appropriate fittings and connectors for the conduit, and avoid sharp bends that can damage the wires. EMT conduit can be used in both exposed and concealed locations, but it must be supported properly to prevent sagging or damage. Romex cable, also known as non-metallic sheathed cable, is a common wiring method for residential applications. It is relatively easy to install and can be used in dry locations. Romex cable must be protected from physical damage, and it cannot be used in wet or damp locations. The size of the conductors in the circuit depends on the amperage rating of the circuit breaker and the load requirements of the equipment. Consult the NEC tables to determine the appropriate conductor size for the application. Overcurrent protection, such as circuit breakers or fuses, is essential to protect the wiring and equipment from overloads and short circuits. The overcurrent protection device should be sized according to the ampacity of the conductors. A ground fault circuit interrupter, or GFCI, is a safety device that protects against electrical shock. GFCIs are required in wet or damp locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or AFSIs, are designed to protect against fires caused by arcing faults. AFSIs are required in many areas of the home, such as bedrooms and living rooms. When working with electricity, always follow safe work practices. Firstly, to energize the circuit before working on it. Secondly, use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Thirdly, test the circuit to ensure that it is de-energized before working on it. Proper grounding is essential for electrical safety and to minimize noise in audio systems. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker and protect against electrical shock. Bonding is the process of connecting all metal enclosures and equipment together to create a continuous ground path. The grounding electrode system provides a connection to the earth, which helps to stabilize the voltage and provide a reference point for the electrical system. The grounding electrode system typically consists of a ground rod, ground plate, or underground metal water pipe. Ensure that the grounding electrode system is properly installed and maintained. Regular inspections and testing of the electrical system are essential to ensure its safety and reliability. Inspection should be performed by a qualified electrician. Testing should include continuity testing, insulation resistance testing, and ground impedance testing. Proper labeling of the electrical panel and circuits is essential for safety and troubleshooting. The panel should be clearly labeled with the circuit numbers and the areas or equipment that they serve. Each circuit breaker should be labeled with the corresponding load. Use a circuit tracer to identify the circuits in the panel. A circuit tracer consists of a transmitter and a receiver. The transmitter is connected to the circuit breaker, and the receiver is used to trace the wires in the wall or ceiling. This can be helpful for identifying the circuits that serve specific receptacles or equipment. When running wires through walls or ceilings, be sure to follow NEC guidelines for protection and support. Use appropriate methods to protect the wires from physical damage, such as using conduit or running the wires through studs or joists. Support the wires properly to prevent sagging or damage. When making connections to receptacles or equipment, be sure to use appropriate connectors and terminals. Ensure that the connections are tight and secure. Use a torque screwdriver to tighten the connections to the proper torque specification. When working with electricity, it is important to have a thorough understanding of the NEC and local codes. The NEC is a complex document, and it is important to consult it carefully before performing any electrical work. Local codes may have amendments or additional requirements beyond the NEC, so it is important to check with the local electrical inspector or AHA. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. A licensed electrician has the training and experience necessary to perform electrical work safely and in accordance with the NEC and local codes. Consider the long-term needs of the audio system when planning the electrical work. Plan for future expansion or upgrades. Install additional circuits or conduit runs to accommodate future needs. Use high-quality materials and equipment. This will ensure that the electrical system is reliable and long-lasting. Document all of the electrical work that is performed. Keep a record of the circuits, wiring methods, and equipment that were used. This will be helpful for future troubleshooting or maintenance. The NEC provides tables for determining the allowable ampacities of conductors. For example, Table 310.16 provides ampacity ratings for conductors based on their insulation type and temperature rating. It is important to select conductors with an ampacity that is sufficient for the load that they will be carrying. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The formula for calculating voltage drop is voltage drop equals 2 times K times A times D divided by circular mils, where K is the constant representing the direct current resistance for the conductor material, I is the current in amps, D is the one-way distance in feet, and circular mils is the conductor area. The NEC contains requirements for the installation of ground rods. Ground rods must be at least 8 feet long and must be driven into the ground until at least 8 feet of the rod is in contact with the soil. The top of the ground rod must be flush with or below the surface of the ground, unless it is protected from physical damage. When installing multiple ground rods, they must be spaced at least 6 feet apart. The resistance of the grounding electrode system must not exceed 25 ohms. If the resistance exceeds 25 ohms, an additional grounding electrode must be installed. The NEC contains requirements for the use of surge protective devices, or SPDs. SPD are designed to protect electrical equipment from voltage surges caused by lightning strikes or other events. SPD must be installed in accordance with the manufacturer's instructions. The NEC contains requirements for the use of arc fault circuit interrupters, or FSIs. FSIs are designed to protect against fires caused by arcing faults. FSIs are required in many areas of the home, such as bedrooms and living rooms. The NEC contains requirements for the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock. GFCIs are required in wet or damp locations, such as bathrooms, kitchens, and outdoor areas. The NEC contains requirements for the installation of receptacles in specific locations. For example, receptacles in bathrooms must be GFCI protected. Receptacles in kitchens must be located within a certain distance of countertops. Receptacles in outdoor locations must be weatherproof. The NEC contains requirements for the installation of lighting fixtures. Lighting fixtures must be installed in accordance with the manufacturer's instructions. Lighting fixtures must be supported properly. Lighting fixtures must be grounded properly. The NEC contains requirements for the installation of electrical equipment at hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. Electrical equipment in hazardous locations must be designed and installed to prevent ignition of the flammable materials. The NEC contains requirements for the installation of emergency power systems. Emergency power systems are designed to provide power to essential loads in the event of a power outage. Emergency power systems must be designed and installed to meet the requirements of the NEC. Proper planning and execution are key to a safe and effective electrical installation for audio equipment.